and welcome to the return of Anglo-Irish Astro Geeks. My great thanks to Pico for playing us in with her beautiful music. And my name's Nicky Betts, FRAS.
I'm Susan McKeown, FRAS.
And yes, we're back. I think the last show we actually did was Asteroid Day last year. So it has been quite a while, but we are here again. It may not quite be every month, but we will be, at least we will do a show and get it up as quickly as possible. So without further ado, Susan, you've got what's happening in the sky tonight.
I do. I'll do the sky notes in a second, but I just wanted to mention JUICE. Obviously, it was launched on April 14th, and it's an incredibly amazing project, as everybody will know, that we're going to the icy moons. It actually stands for the Icy Moons Explorer. Launched, it was on 14th of April. Actually, Andy Briggs on Space Odysseys did a great live cast of it going, and I'd like to thank him for some of the notes he gave me. It won't arrive till 2030, and of course none of us want to wait, but we're going to have to wait. But it's going to be actually characterizing different planetary objects between possible habitable worlds. Even the fact that they say that is exciting, that they're even thinking that that might be something. It's been launched by the European Space Agency, which again, fair play to them. There's 10 instruments on board. There's only one of them actually from NASA, but they're from all over the world. So it's a bit of a, a bit of a project and cooperation between a lot of people. But it'll map Jupiter, and Jupiter will become the archetype of gas planets for our whole universe. So I just wanted to mention it, and it was great to see it go, even though the launch was scrubbed a couple of times. It was great to actually see it go, and I clapped by myself.
Well, also the last Sky at Night did quite a big bit about the JUICE missions. Because I think it's Michelle Doherty. At Imperial College London. She's working on the mission herself. And of course, it is an opportunity to find life inside our extraterrestrial life in the solar system. And
absolutely,
perhaps the best places for it is going to be Europa, possibly Ganymede, Aeatus, and even Titan. Has the possibility to host a unique form of life, even though it has lakes of petrochemicals. But it's one of most things. Europa to me is the best bet because it's an ice-covered planet, but between the ice and the rock is believed to be a warm-ish saltwater ocean. And given how life started in the Earth's oceans, it may just be simple one-celled life. It could be complex groups of cells. We don't know. But the important thing about JUICE is it is the pathfinder, literally, for Europa return. What JUICE does will also help NASA's mission to Europa, which is going to land on Europa. And that could really open up a lot of interesting discoveries. The other thing is, it's going to tell us why Jupiter's moons have active cores and have magnetic fields and have potential, I'm going to use the word potentially, a biosphere there. So that's the great thing about JUICE. It's leading the way for an actual landing on Europa. And it does mean an awful lot.
It does. It's incredibly exciting. And I mean, obviously, we have to wait till 2030. But we'll see plenty on the way. Actually, David Moore from Astronomy Ireland actually managed to image JUICE at 670,000 miles the other night with his telescope. So, I mean, it's already being great. It's already giving us information. It's something to do. It's something to look at. It's wonderful.
Well, the other thing is with it doing a planetary assist, planetary flybys to get some extra speed to get to Jupiter, it means that they can test the instruments or it's beyond reasonable distance. And I believe that is one of the things Michelle is looking forward to, is the magnetic interferometer. I think I've got that right. will be extended. It'll be switched on relatively early in the mission, which allows them to test it and to make sure it is fully functional.
It's working, yeah.
Progresses.
Yeah.
So yeah, it's definitely going to be one to keep your eye on. And of course, the more we learn about the mini solar system within the solar system, because really, if you look at the Jovian satellites, they are just like a solar system.
Absolutely, they are.
Yeah. It belongs to Jupiter, and to some degree, it's the same as Saturn. And it could also perhaps pave the way to missions to other ice giants. Certainly, it's about time we went back to Uranus and Neptune. They've only had flyby missions. We have ion drives now, which means we can go into orbit much easier, and then we can leave orbit and move on to the next target. And I think what New Horizons has taught us is that there is water on Pluto.
Yeah.
And if you've got water, you have the potential for some form of life, because it seems to be a universal. Well, for us on Earth, it is certainly
for us. Yeah. For our type.
The majority of biological life. Now, whether they on other planets or other moons, they live in extreme environments, like around the black smokers on the bottom of some of the deepest trenches in the oceans. We will find out eventually, and I think part of that investigation will be done by missions like Europa Direct.
Yeah.
So we have an awful lot to listen to and look forward to coming back. And of course, get out there, look at the planets, image the planets, and share your pictures on social media. Because in a lot of respects, the best thing that we've learned is particularly from Juno, is that we can get the raw data from Juno and we can process the images ourselves. The images that have been produced haven't been from NASA. They've been from individual amateur astronomers who are taking the raw data from Juno and putting it out there. So in a lot of respects, doing that gives the American expression, I believe, is more bang for your buck.
Bang for your buck,
less, because you have an amateur astronomer community that can provide image processing literally as good as they do with Hubble. So yeah, it's going to be good. The ISS
was Hubble 33 this week as well. I think Hubble was 33 this week as well, which, by the way, I didn't realize.
And of course, there are other telescopes, optical and near infrared, on the table. There's one that's being processed that will put the Hubble into the shade. I think it's called Lucifer or something, but it was definitely mentioned on the sky at night. And they are going to be looking at exoplanets with this telescope.
Yes.
So what's the technology is literally leaping ahead. But enough of this, because this is something we're going to touch on later in the show.
Now, with Kevin.
Do you want to quickly tell people about the visibility of the ISS and what's...
I will, of course. I have some sky notes here. So the ISS is not really visible at the moment until the 28th of April. As Nick said, there is an app you can track it, and you could actually talk to the astronauts. What is it called, Nick?
It's called Heavens Above, and what you need to do...
Heavens Above, you
need to set it for radio passes as well as optical passes, because there's an awful lot more radio passes with the ISS than you can actually, the ones you can actually see it. Now, if you've got a 2-meter receiver, that's 144 through to 148 megahertz, you can pick up not only the conversations with the astronauts and school kids, you can pick up the repeater that's on board the ISS. And a lot of people use that repeater to do pretty much over the horizon VHF transmissions. So because of the height of the ISS, effectively your radio signal goes like that. And they meet at the ISS, go through the repeater, So, say for instance, a radio amateur in the UK could theoretically speak to a radio amateur on the other side of the Atlantic, or meters, because being VHF is not a particularly long distance. If you want long distance communications on amateur bands, you go to high frequency or HF, which is 1.5 through to 30 megahertz.
Yeah.
But anyway,
well, the other big thing this week is Venus is passing between the Hyades and the Pleiades, the star clusters. It can be seen naked eye for the next week or so, which, I mean, will be an amazing thing to look at. Today, Saturday, the moon will be near Venus, including tomorrow, Sunday. The moon will be near Venus again. So on April 25th, the moon will be close to Mars. So we have Mars and Venus all kind of visible the last day or two and into the next day or two. All of this information is available on the astronomyireland.ie website. But you should definitely try and have a look at Mars maybe on Sunday, because the moon will be so close to each other.
There was a radio show that you also wanted to tell me about.
Oh yeah, I want to thank Andy Briggs from Space Oddities. He gave me all the information for Juice, so I really appreciate it. They're on at 8 o'clock every Monday night. So Space Oddities.
Well, so earlier this week, as you can see, I'm wearing my Rogue NASA shirt this week. We actually recorded an interview with our guest. Our guest is no stranger to Anglo-Irish Astro Geeks. In fact, the last time he was on the show with us, we had a very great in-depth discussion about Mars. Actually, I would have said it's more an excellent lecture about Mars.
Yeah.
So without further ado, I'll hand it over to our earlier selves, earlier this week, interviewing our guest. And would our guest this month like to introduce himself?
Yeah, hello, my name is Kevin Nolan. I'm an astronomer and physics lecturer in Dublin, and basically doing my research in astrophysics. Still doing my PhD quite late because I returned to academia from the computer industry in software for the European Space Agency, and then love science outreach and astronomy and space outreach in particular, and have been a long-term volunteer for the Planetary Society and love talking and debating everything space and science. So thanks for having me, Nick.
It's great to have you back. The last time was a couple of years ago, I think now. And really, Mars is a subject you really can't cover it just in one show.
Yeah.
So here we are again. Obviously, we've got sort of things we can discuss. So let's get cracking. Mars actually is back in the news. Sometimes for good reasons, sometimes it's like the half-baked reasons, I think we can probably say.
Yeah.
The rovers are doing great work.
Yeah.
In fact, the first of the Earth return capsules have been dropped by the rover, ready for collection. That's probably the next big Mars mission, really.
Yeah.
So thinking about that, what other type of things we're going to be looking for, do you think, we get those samples back here on Earth?
Yeah, I mean, as you say, Nick, it's a great time for Mars exploration. And, before we just step into the Perseverance rover, capsule drop, let's just address that for a bit. I mean, it's funny, as we get a bit older, I become maybe a little bit more cynical or less tolerant of younger people's naive views on space exploration. And I've got to temper that, because when we were young, everything was possible. And so sometimes if we hear of people saying we're going to colonize Mars using SpaceX Starship within 3 years, and I cringe online hearing that. But by the same token, you have a generation of young people now believing this kind of possibility, and that's got to be nurtured and encouraged too. But I suppose what, as again, being slightly older and about this and having us lived through the era of robotic Mars exploration from Pathfinder in '97 to now, what I feel doesn't get due coverage, and why I got interested in Mars around the year 2000, was that there is really genuinely an amazing program going on that is a multi-decadal program. In fact, as you know, I wrote a book called Mars, A Cosmic Stepping Stone in 2008, and that was based on an amazing document released in 1995 called An Exobiological Strategy for Mars, where 19 top Mars scientists in the US, including Carl Sagan, who died just a year later, basically said that they felt from the Viking orbital evidence that there was about a similar probability that life could have arisen on Mars as Earth, and that mandated a search. But what they decided to do, because NASA recoiled with the whole Viking lander missions in the 70s, what was they decided they'd do it in a phase. They actually said at the time a 5-phase strategy, which isn't that well known, but which they're broadly pursuing, which was phase 1 orbital reconnaissance, phase 2 geochemical landers to characterize the surface chemistry, Spirit, Opportunity, Pathfinder, and Curiosity, and then exobiological landers, of which Pathfinder or Perseverance is the first, then sample return, which is the next phase, and finally then humans to Mars for scientific reasons alone is all they mapped out here. So, the thing, as I say, to get back to the central point, is that I think this has been an incredibly successful campaign, because we've fully characterized the geochemistry of Mars. We know it was and is very much characterized by water, that it's got a very similar surface chemistry. The more we look for habitable sites, the more we find, and there's no signs of that abating. So, like where Curiosity is, we know that Gale Crater was habitable. We've even found organic molecules inside mudstones from that lake billions of years ago, and now Perseverance is finding the same in Jezero Crater. And what's kind of more exciting about this is the instrumentation as well. If you look at Curiosity, in fact, a lot of people often argue saying we're so slow on Mars, we haven't found life yet, but none of the rovers to date have been looking for life. They've only been characterizing the chemistry, albeit Curiosity has this amazing what they call X-ray diffraction spectrometer on board, which was what we use to characterize the structure of DNA, and it can therefore analyze the molecular structure of organic molecules on the surface. But Perseverance has even better instrumentation, in particular one called a Raman spectrometer, which can determine the nature of organic molecules and whether they are maybe possibly biogenic in origin, because it can Raman spectroscopy analyzes double bonds as single bonds in organic molecules, and we can infer whether they may have been manufactured by biological processes as a thing from inorganic processes. So Perseverance itself has great science to do on its own on the surface, and is fully characterizing Jezero Crater. Again, is being looking, if they haven't declared it yet, like we have a Gale Crater, but it really does look like it may have well been habitable in its past. It's going in that direction. And then, as you say now, it's laying down these canisters with very interesting samples within them. And I kind of like them almost like a trail of breadcrumbs, because as you know, we can't land precisely on Mars. We've got that circle ever smaller. So the point being, however, that it lays them down over several kilometer distance, so that again, at the end of this decade, when we send a sample return mission to the same location, and that's a joint mission between Europe and America, which is very exciting, that will, and that's the format of that actually mission, sample return mission, is simplifying and changing all the time. It's not set, but basically the objective is to send another lander there, in fact, probably a rover, collect some of the samples. NASA will launch them using a small Mars ascent vehicle into Mars orbit. And then the European Space Agency, and they're building it right now with Airbus, are building this massive 6-ton, or I think it's more than 6 ton actually, but anyway, a big orbiter that will scoop up these samples and bring them back to Earth. And as you've probably heard, we all have heard this one, that we can do more in an afternoon in a lab on Earth than we can do in a decade on Mars with a rover, which is largely true, because as amazing as the instrumentation on the rovers is, nevertheless, the sophistication of what we have in modern analytical labs on Earth is mind-blowing. So we probably could get to quite definitive answers about, the potential for life on Mars. And again, I'll remind anybody listening to this, is that the objective, success isn't proving life was on Mars. Success is understanding what Mars has to tell us about life, whether it did or didn't form, because it really was quite similar to Earth in its beginning. And if life didn't form there, that story will potentially, at least in the science terms, be as interesting as why it did evolve there. So we're on target. Perseverance is doing a great job. It has loads of science itself to do still. And then, as I say, it's just wonderful that it's laying down these capsules for collection later in the decade. And as I say, the missions to collect those samples are being built. The contracts are being signed. This is no longer notional. We really will have a sample return mission within the next 10 years, which is just fantastic. And then the science we hope to get from that will be quite definitive quite quickly, actually. I think that'll be very exciting time scientifically.
Well, one of the things that has happened, and I know that Susan's been interested in it as well, is the fact that over the last decade, the actual technology we're cramming into the rovers has improved exponentially.
Absolutely.
And the way they're going to do the sample return mission, in a lot of respects, it does pave the way for an actual manned mission to Mars.
Yeah.
Because the technology they're using to return the samples
Yep.
will possibly be included in the actual manned mission.
Yeah.
To get boots on the ground to do a proper Mark 1 eyeball, as they call it, look at Jezero crater or Gale crater, or even somewhere completely different. We, as you point out, we know there was water there once upon a time. We know that after Mars's magnetic field collapsed, the atmosphere was stripped by the solar wind, and it dried up. In fact, the interesting thing is the dichotomy between the various areas in altitude, because you've got the low-lying areas of Mars, which were possibly seas, and you've got the higher areas, which would have been dry land. And of course, there was volcanism, and it was quite effective at laying down material. It shield volcanoes because of the lesser gravity. Whereas on Earth, we have stratovolcanoes, which are very much different. But the majority of Martian volcanoes, from what I've seen, are all of the shield type. They're the Hawaiian type.
Yes, and indeed, sorry to interrupt, and I don't, Susan, interrupt it, please, if you want to. But you're right.
No, I'm listening away. Yeah, I'm listening away. You go ahead, Kevin.
Yeah, well, actually, there's two big areas you've addressed there, Nick, which I think are wonderful about Mars. Is that definitely, these shield volcanoes in the Tarsus region in particular, we now have characterized and nailed them down to saying that they laid down their lava in Mars's early history. So, and in fact, we've already computed that the amount of carbon dioxide they would have emitted would have amounted to a 1.2 bar atmosphere. So, in other words, we're pretty certain it did have a fairly dense carbon dioxide atmosphere in its early history. Whether it was enough to give global warming to actually allow liquid water to flow is still a debate, but I think you're right. The consensus is converging on the idea that there might have been a great northern ocean. It probably would have been quite shallow, but it was nevertheless a lot of liquid water potentially there. And we know there were lakes and flowing rivers as well, of course. But to get back to your point about humans on Mars, and this is, I suppose, the great intriguing future we have. We almost have like two parallel universes going here. We have the SpaceX thing, whereby if they really do get Starship working, could short circuit what is the more conventional idea that NASA has for sending people to Mars. But even the conventional one by NASA is now converging in two fronts, and you've just nailed one of them there. So if we finish the sample return, then we've completed the cycle of getting to Mars, soft landing with accuracy, and then returning to Mars. And all of the, okay, it might be smaller vehicles, but nevertheless, the rovers are a ton in mass, and we're placing them down with great nuance and care. And then, as you say, sample return will give us the understanding of the dynamics of getting back to Earth. And then if we look at what's going on with Artemis and the Lunar Gateway, and I've read a little bit about this in the last year or so. So like they really have one eye on Mars with all this now. Not just the original idea of the Space Launch System, or Ares as it was called, was to build 2 human-rated missions in Earth orbit, each around 125 tons each, and then one to go with supplies, and then to send the second one with humans 26 months later. That's kind of scrubbed, but a variant of that is emerging. So if you look at the Lunar Gateway in particular, and the IHAB module that Europe are big involved in, so basically now what they're looking at is that Artemis, or the Space Launch System, is good enough to build a Lunar Gateway, by which we will build the habitation modules, the energy, and the propulsion that we would then use to piece together a human-rated spaceship to go to Mars. So an awful lot of what we learn about landing on the moon, sending people to the moon, and in particular building this Lunar Gateway, which has been quite contentious, because the big debate is, should we go to Mars straight off, just get there, or should we go to the moon? And an awful lot of people are more impatient about it, saying, well, why are we going back to the moon? Let's just go straight to Mars. But whatever the rights and wrongs of that debate, nevertheless, I think it's lovely to see that the heavy duty learning of how to hold people in deep space and to build deep space energy system or propulsion systems needed for Mars are being kind of addressed by the Artemis missions. So now if we can kind of bring what's going on robotically on Mars together with what's going on human deep space exploration with Artemis, we can see a convergence there, bring those two together, and suddenly then maybe in the 2030s and 2040s, you can visualize the likes of at least a flyby of Mars, maybe landing on the moons, and you know, getting down to the surface is, as they call it, the big delta G is a big expensive extra step in this that even the likes of SpaceX aren't thinking about, by the way. They kind of may say they are, but it's very, very hard to get down to Mars and come back up again. But nevertheless, you're right in as much as it is wonderful to see that we're moving forward again. Now, I happen to be somebody who, I don't care if this happens in my lifetime or not. I care that we do it right. And I don't mean to sound all magnanimous about that. I really feel that. I don't want to muck this up, because then if we get it wrong, we could be decades waiting. Let's say, for example, we try and get people quickly to Mars and they die en route. You could easily imagine the likes of NASA recoiling from it for the next 30 years type of thing, you know?
Yeah. Sorry, Kevin, do you think that they have unrealistic expectations of what colonization of Mars is? I mean, you see what we see on sci-fi TV programs, all that kind of stuff. We can't live there. That's not the environment where we should be. We're humans, we live on Earth. Of course, I understand we want to go, but I mean, realistically wise, you know, getting there, landing, getting back up, all these things are not easy to do. So nearly impossible.
It's funny, when Elon Musk came along at first about 10 years ago, and even the Planetary Society were waxing lyrical about him, and he kept saying we'll have people on Mars in 3 or 5 years. I mean, I as a you know, growing old science outreach person, was afraid in public to contradict his intentions, because you're kind of seen as a killjoy, a spoiler of the party. But now I feel what he kind of says has to be understood maybe a bit better, not knocked, because I think it's right that people have aspirations, ambitions to go further. But by the same token, I think the problem is that if he's saying these things and they're unrealistic and they're currently letting people down, then you've got to ask the question, is these kind of crazy declarations doing more bad than good? Now, if you just look at the economics alone, if you just think of the International Space Station costing $100 billion and it's in low Earth orbit, and if you look at any of the pictures that are portrayed by the SpaceX camp as to what even a small colony on Mars is, it's multiples of the International Space Station. So their ideas are laudable, but what they've put on the ground is trillions of dollars worth of hardware. And actually the world can't afford that. And the world will not tolerate it. I mean, you can knock on the door of everybody you want, but you will not get a private investor to sink $2 trillion into a human colony if there's no financial return, you know? So I think there has to be a little bit more realism, even in terms of the raw economics of what is and isn't possible. The Lockheed Martin actually worked with the White House there about 3 or 4 years ago, and they did a case study. Now, by the way, Lockheed Martin are, you know, for all of their military contentiousness, are a company to listen to in this. They put an awful lot of thought into things like this. And they reckoned about 3 or 4 years ago that the cheapest we could do a Mars mission was a flyby of Mars by the mid to late 40s for $160 billion. And that wasn't stopping there, you know? Now, again, we do have to actually temper all this by saying that if SpaceX really do build a Starship, or if NASA really do perfect nuclear thermal rockets, you know, maybe then all bets are off and we can do this quicker, you know? So you don't want to be never say never type of thing. But in my view, even with SpaceX, what they're building is a chemical rocket. That means you've got to adhere to the laws of celestial mechanics. You've got to have a journey that's every 26 months. That means you've got to have lots of supplies. You've got to have 4 or 5 people. There's where the costs mount, you know? If we can short circuit there and get to Mars in 5 weeks with new types of nuclear rockets, great. That's different. You might be talking 3 months in total. But if you're going to even use the Starship to Mars just to land on the surface, come back up and come back to Earth, you're talking about a 900-day mission of 3, 4, 5 people.
Which humans are not. We
don't even know if we can do it.
We can't physically, but emotionally and mentally, all those kind of things. We're not there yet.
Susan, you nail it there mentally. There's a very interesting report again that was put out to say that if you sent 5 people on a 900-day mission to Mars, like, you know, the way we lose bone mass. Well, this study is pointing out that you don't just lose bone mass, you actually lose metabolism in all cells the body, including brain. So they were saying that there's likely to be several bouts of clinical depression during that mission. And what if the person who's suddenly depressed is the pilot to land you on the surface?
Yeah.
Well,
so, I mean, yeah, exactly. I mean, realistically wise, I mean, they really.
Yeah, we're not there yet. Yeah.
Yeah, it's still pie in the sky, even though don't want to be a killjoy, it still is.
Well, one of the things about CIS Lunar Gateway is by going back to the moon, we are perfecting the systems that we are going to use, we have to use to go to Mars.
Yes.
That's long-term moon bases, even if it's a regular turnover of crews. By having a facility on the moon, you can test in lunar gravity everything you're going to take to Mars, including a potential Mars buggy or moon buggy, probably with exactly the same piece of equipment, just packaged up to go. So you can test your propulsion system for the trip to the moon. You can certainly test how you're going to feed the crew, hydroponic gardening. You can perfect the equipment you're going to use to protect them from solar storms and cosmic radiation. Best thing in the world is plastic. The people don't realize it. You have a plastic cube with water in between the two layers going through an airlock. You're actually protected much better from secondary radiation, alpha, beta, and delta particles, because they're not going through metal. When cosmic rays go through metal, they spray off additional particles, and that's where a lot of the risk is for space travel. You also need to perfect a system where you can produce gravity on the trip. So my favorite example was the BBC docudrama Voyage to the Planets. They had a module that rotated on the spacecraft where you could build it up to at least partial 3/4 Earth gravity, at least. That helps you in a lot of the things like bone density, brain mass, and metabolism, because you're living under a form of gravity. You might commute into the 0G areas for your labs, for your spaceship control areas, and to do EVAs. But at least you've got a form of gravity that keeps you in trim. You could have your workout room in the 0G module if you wanted, or you can put it into one of the gravity areas. But that's the type of thing we have to perfect. And to be honest, Earth and lunar orbit is the safest place to do it, because it's the quickest place we can mount a rescue mission.
It's the only place we can do it.
This is big.
And the point is that even I don't know what the longest stay in space has been. It's probably 300+ days, and we're still talking about 3 times that. Go to Mars. We simply do not know how the human physiology will respond over 900 days. It's a career, once-off career trip, no doubt. We know that, but as you say, we have a massive amount to learn about long-term, and it's not looking great. I mean, the longer you stay in space, the more deterioration and life-changing phenomena occur within your body. So, as you say, Nick, this idea of just kind of being able to, work out and is not enough. We do need to examine the notion for 900 days, as long as it's 900 days, of some sort of artificially generated type of gravity system. Even that probably won't be sufficient, but it's the best we can do. Now, as I said, this is all assuming we're going to Mars using chemical rockets. If we do perfect, and I've just read something the other day that now there's an international treaty that says you can't launch anything nuclear into space. That's why even putting nuclear what do you call it,
the strontium-90 snapback.
That's an issue these days. But however, NASA are keen to actually test nuclear thermal rockets in space again. And if ultimately you could send people, short circuit them across the solar system, and get there in 6 weeks, it's a totally different thing.
It's a totally different. You're playing a different game.
I would even argue that maybe Mars is just always going to be too far using current rockets.
NASA had the NERVA program back in the 50s and the late 60s, early 70s. The test ban and outer space treaty came into effect. Therefore, the rocket couldn't fly. Having said that, the exceptions that are made are for space probes going into the far solar far edges of the solar system. They've demonstrated quite convincingly that the actual capsules, that the radioactive material is that powers the probes, is unbreakable. They deliberately blew up a rocket with one of these capsules in it with a low radioactive gas in it.
Right.
And when they recovered the actual container, it was intact. There was no leaks.
Amazing.
And it proved that it was safe to use this material on space probes. So we know we can do it. We just need to, obviously it's going to be scaled up. However, the best way to do it, build it in orbit. Because that way, if there is an accident in orbit, theoretically, it should not affect life on Earth.
There's a small risk. I mean, even if Cassini had it destroyed, because it had to do flybys of Earth for gravity assist. Like I worked with or a colleague of mine worked at the Irish Radiological Protection Institute of Ireland, and they had worked out that there'd be a risk of three deaths in 50 years from the radio. There was a crazy statistic, and they actually published it all over the press here in Ireland. And, I was called on to argue against it. So they kind of created not a scare about Cassini flying by, but you probably remember there was a bit of international hullabaloo about it because it's not a zero risk. It's very small. But,
it's negligible, but it's there. Yeah.
It's there. Yeah.
But then again, space travel is all about risk. And that goes back to Apollo 1 and Gene Kranz. I think it was Kranz. He said at the inquiry into the Apollo 1 disaster, what would Gus, Roger, I can't remember the other guy's name, which is terrible, I know. But they said, what would the three guys say? They said, go ahead.
Yeah.
Don't let our deaths be in vain. We learned a very important lesson. We need to improve. We need to fix this. Take out all the Velcro that they were using in the pure oxygen atmosphere for tests. The capsule was much, much safer.
Yeah.
So
I understand that point. I suppose if in a sense, that's their choice. You know, all astronauts' choice. They know the risk. I suppose the argument about putting nuclear, any sort of nuclear power in space, there's twofold concerns. One is if there was a breakup of such a vessel and the spread of radioactive material across the upper atmosphere, and therefore, acting as some sort of contamination of a broad populated area. As I said, that risk is very small, but nevertheless, the people living there don't have the choice. And the second one is, I always remember Carl Sagan making the point that if you put nuclear weapons in space, then you're not worried about the USSR at the time versus the USA. You're worried about if they're in space for 100 years, some crackpot is going to come along and get the codes and use them. So you just don't want that kind of power in space in any way. So if you're going to loosen the shackles in terms of using nuclear power in an innocent, let's say, put way or a societal way to get people quicker to Mars, then the argument comes along: can we put nuclear power in space for other reasons as well? And so I suppose in a sense, the bar has to be very high, and there has to be very broad agreement in this until before we actually go and do anything. And a slight concern for me these days actually is, I mean, we all know the world is more fractured than it was, say, 10 years ago, is that the USA in particular seems to be quite going it alone in terms of actually how they're using the space, particularly in the FAA giving licenses to SpaceX for their Starlink in mid-air to orbit, from about 200 to 700 kilometers, where it's unregulated legally. Now, so the point is that, and I purposely on Facebook follow like SpaceX and other similar groups, and they're very, very divisive. If you say anything against SpaceX and Starlink, your comments are removed from these groups because they're ideologically driven. And the thing is that kind of saying it's free space, it's ours, we can do what we want with it. That's all well and good, but if you're not going to work with international partners in this, then we're just going to see a divided use of space into the future. And so I suppose what I'm trying to say is, it would be lovely to see a safe development of nuclear power to get us to the planets, but it has to be within a broader context where there is complete agreement. And even if the likes of the Russia or China come along for purely political reasons now and say, no, you can't do it, then I would like to think the USA or Europe would say, okay, we won't do it because of the political risk associated with it. So I think we have a long way to go, even if the technology
I think you're expecting a huge amount from diplomacy that I don't think is there in a lot of people.
Not there at the moment.
I mean, but fingers crossed, you know.
Yeah, yeah.
I think one of the other things is once the technology's been proven, nuclear propulsion, we can look at perhaps revisiting older ideas like the Atlas. We could actually bootstrap something up to almost what they said, 75% of the speed of light. Yeah. Send a probe outside the solar system.
Oh no, I love that. And even, you know, it was a breakthrough star shot. You know, I know it's a bit dormant at the moment. I suppose it was a Russian oligarch who was kind of funding it. I don't know that right now. But the idea of sending this tiny probe to to Proxima Centauri, and in fact, I have to tell you, like, you know, steering off Mars, a talk I want to put together to give, and I think I'd love to see a few more books written on it, is just about where we're at with the outer solar system and just beyond the solar system. If you take a look at what we're doing right now, so you have New Horizons still, you know, active around the Kuiper Belt region, probably going to go to one more object. Voyager's traversing into interstellar space. The Nolan breakthrough starship. What I will say to any
just launched on Thursday. Yeah.
Sorry.
Hughes just launched as well. I mean, there's loads going on. You know.
But I mean, that's going to Jupiter. But I mean, really beyond the solar system. Let me put it this way: any young person now getting interested in space, they know they can say something we couldn't say when they were young, which is we've gone to Pluto.
Yeah.
And so their ambition will be beyond Pluto. And then, are you aware of what's called Pale Red Dot, which is a program to find Earth-like planets around nearby red dwarf stars? And the first discovery of that was Proxima b. Yeah. And so now we know of an Earth-sized planet around Proxima b. So there's your destination. You know, so I think there's an awful lot going on under the hood, under the radar. And there's all sorts of radio telescope missions to map the interstellar medium just outside our solar system with great success. And then, like, one of the amazing statistics of it, I don't know if you ever saw when Boeing released the brochure for Space Launch System. I know there are years late and all that's what we could get into that, but they had this amazing brochure about 7 or 8 years ago, which isn't on their website now, but I downloaded it. I have it on my computer here, where anybody could buy the Space Launch System if you had the money. And they outlined 25 different kinds of missions that you could do with it. And one of them, which is this is the extraordinary power of space launch. I know Starship will be more powerful and all the rest of it, but with the Space Launch System, it could get a kind of a Horizon or Voyager type space probe out to 200 astronomical units in 15 years. Now, I did some calculations that would get New Horizons to Pluto in 3 years without a gravity assist. So the thing is that, like, that's the power of rocket. It could get a probe to the moon in less than 8 hours. Isn't that amazing?
That's amazing. Yeah, so that's fascinating.
We can start thinking about sending probes to outside the solar system. And you might think, why? What's out there? Well, to know the Milky Way region and to know what's out there, and then to come back to your idea, Nick, to understand what is the interstellar medium we would interact with if we're traveling at near the speed of light. I think it's interesting that this generation is starting to think about that kind of problem, which is, how do you travel at maybe a fraction of the speed of light between here and the nearest star? They're not, farcical ideas anymore, which I think is a wonderful thing at our age, you know?
They're doable. Well, they're maybe doable, which is better.
Well, we're thinking about it, you know?
Well, we also got the ion drive at last. NASA's been using it, some of its solar system missions.
Yeah.
It's definitely used it to go to minor planets. Ceres was one of the places they actually sent such a drive unit. And it's incredible. You have so much more you can do with the probe. You don't have to do just a fast, dirty flyby.
Exactly.
You can now go into orbit of these places. You can do a very deep resolution scan with radar of what the planetoid is really, really like.
Yeah.
And you can actually see a lot more detail.
Yeah. And the other side of ion drive is, unlike, say a probe to Mars, where all your acceleration is done just outside of Earth orbit, and then the rocket stops and it's on a free fly there with no extra propulsion. With ion, it's a very, very gentle acceleration, but it's consistent all the way to your destination.
Yeah.
So it becomes a huge acceleration over time. And as you say, we could definitely enhance ion drives to get outside the solar system. And we might be 20 years waiting to get to Pluto, but then it'll get 100 times the distance of Pluto in the next 20 years.
Yeah.
It's just persistent, slow acceleration, you know. So it's a wonderful technology. Again, the thing is, I suppose with some of these things is they go beyond one lifetime in terms of the ambition of them, and that's why they can seem like very slow burners. Even if you take any mission, say like the one I'm involved in, my own PhD, Integral, was originated in the 1980s and it's still up there working now. So any mission takes decades to really fulfill. Yeah. And things like nuclear power rockets or ion drives are even longer burners, excuse the pun. You know?
Well, yeah, the Voyager probes were transistor logic.
Yeah.
They were big, they were heavy, transistors, these individual devices. But look how good they are in space. They take all the punishment from the radiation, they eat it up, they keep working. Voyager 2 is still calling home.
It's incredible.
And when you think about, compared to perhaps New Horizons, Voyager 2 is very, very crude in technology.
Yeah.
But it's really, really worked.
Yeah.
And it showed us what we can actually do. It's 60s technology. It's brilliant. Nobody really thought we could track them, yes. Yeah. But we never thought we would actually get reports from beyond the heliosphere. And we're getting that.
Yeah.
And we're learning so much about the interstellar medium from that. We're even finding out that actually our solar system technically extends nearly halfway to Alpha Centauri.
Yeah. Yeah.
So that is quite a huge leap in the size of the solar system.
Yeah. 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 No, it's extraordinary. It really is. And talking about old technology, just for preparing a talk on web recently, I decided to download one of the documents, actually the service document for the last service of Hubble. And I was shocked to learn it has a Pentium computer on board, right? Remember the old Pentium? And it restores all its images to tape on the machine. Tape.
Actual tape.
Yeah. It doesn't use RAM.
Well, tape drives
it's incredible.
Probably twice or three times the size of this. This technology is space technology.
Yeah.
This is what NASA and the European Space Agency gave us in return for our tax pounds, euros, dollars going into the space program.
Yeah.
The cameras alone came from that. They also came from the surveillance programs that were launched against certain countries. We'll leave it at certain countries, but the kit gets declassified.
Yes.
And it trickles down. It's trickled down science and technology. We get to play with it.
Any money we spend on space, we are getting back in space. We are getting back more technology. It is an investment in humanity. It's an investment in the future. It's an investment in every child on the planet. But people don't see it that way. They see it spending big amounts of money on space travel, but you're spending big amounts of money on the future.
Yeah, you're totally right. I mean, as they say, there's only 4 or 5 ways that we really innovate a society. And like most of them are negative, like war or pandemics. But space is one where we innovate truly in a global way that can accelerate. Like I again read this recently that it's really crystal clear that the Apollo program accelerated the integrated circuit industry in the USA by 10 years.
Well, without Apollo, we wouldn't have had our personal computers.
Exactly.
Started militarizing everything to fit the Apollo weight requirements for a spacecraft. Valves are heavy. Valves need high tension electric provided. You can't do that in space. Not
without Star Trek, we wouldn't have had any iPads, you know.
Exactly. An integral part of the space program, really, because in the Dragon capsules they use iPads. The actual if you look at when they're doing the launch, the astronauts are doing touch screen work on an iPad.
Yeah.
On the ISS, a lot of everything is done through tablets. Totally.
Yeah, and they're movable as well. You know, it's just better technology which moves along because of that.
The other good thing about it, space or near space, Leo and maybe even a high Earth orbit is a great place to look at pharmaceuticals that could eventually, which would save a life down on Earth.
Yeah,
you could probably have a lot purer reduction up there than you can down here.
You're dead right. And actually, I teach physics to pharmaceutical science students in Ireland here, actually. So I kind of keep a tab on that. And the European Space Agency are investing big in this in the next few years. And they've actually, they're constructing, you know, this is the Vega rocket. It's a new small reusable rocket. But in any case, there's also a small flyer that they're using. It looks like a small little shuttle, but its sole purpose is to fly into Earth orbit to run pharmaceutical tests. So they'll be contracting it out. They'll be licensing it out to pharmaceutical companies just to be able to do trials on low or microgravity environments and how they might affect actually pharmaceutical production and process. So you're absolutely right. I don't know any more in depth in it, but it's a big growth area for ESA in the next 10 years. That you know, is to help grow the pharmaceutical industry in space.
In fact, you know, space medicine is already a booming place to be if you're a science student. If you're into medicine already, taking the next step and going into space medicine is where a lot of employment is going to be, because we're going to have more habitats in orbit, and we're going to need doctors and nurses to staff them, because it's not cost effective to keep shipping people home if they're ill or have an accident. If you have maybe 2 members of staff, like a doctor and a nurse, permanently on a space station. Each station's got their own medical facilities. Therefore, you can treat anybody that has an accident or is ill there. You're saving money. And also, in a lot of respects, by not constantly using propellant, you're also helping the climate in a lot of respects as well. So there is a lot that can be done, and it trickles down. One of the doctors might be doing his favorite research project. He might actually, doing his research, find something which will have a huge implication for geriatric medicine on Earth. In fact, I know that in a lot of the older science fiction stories and a lot of the older science magazines, one of the concepts they were looking at is a home in space for elderly people, because the pressure is off their heart, they can live longer. Because the microgravity.
Microgravity would be actually, do you know what? That makes a huge amount of sense.
It's a wonderful idea, isn't it?
It is a really good idea, It's again probably well down in the future, but it makes sense.
I mean, whatever about the moon and Mars, low Earth orbit may be revolutionized in the next couple of decades in terms of far more access. Now for thousands or millions of old people, probably not, but nevertheless, we can't visualize what it would be like, say, in 100 years. It may well be that this is quite a plausible
doable, and
or maybe for recuperation, who knows. I mean, I know actually, getting back to just medical staff in space, that again, reading NASA's what they call them design reference missions for Mars. If you have a 900-day mission with 5 people, one of them will have to be trained in surgery, because they estimate at least one required operation to be performed during that 900 days, which is an extraordinary thought, of the
it's all sorts of stuff that between the 5 that would have to be trained for, and you'd be hoping that the person that you need at the time is not the one that's sick. It's a huge operation to even think about, but
I mean, if there's one element of space exploration today that I just feel is a little bit lacking, is just in terms of kind of, I suppose, ethos and vision. We were lucky to grow up in an age with 2 of the greats, Carl Sagan and Patrick Moore, and I don't really quite feel we have that at the moment. So for me, for a lot of young people, when they, I don't want to sound like too anti-SpaceX or Elon Musk, because I think SpaceX is an amazing company. Elon Musk can be divisive, but I feel as if the young generation are missing a Carl Sagan, because space exploration was more about an ethos of a positive, almost like the Star Trek thing, a positive view on humanity, reaching for the stars and doing things in an international way. Like, certainly as I was a kid, it was always envisioned that the only way to get to Mars was if it was true international collaboration between Russia, China, and America, see that back. So while we've got wonderful programs, wonderful missions, I worry a little bit that maybe, and even this business of SpaceX versus NASA, that narrative in the USA is very potent, and it's also aligned along left-wing, right-wing politics as well. And I'd love us to see get away from that a little bit. I'd love to see I mean, I love Brian Cox, I think he's great, but I don't think he's that visionary messenger.
Yeah.
Or Neil deGrasse Tyson either, by the way. I don't think I quite reach that level of communicating and ethos. And I you know, for young people today, and I worry a lot about this because I'm teaching first year students in physics an awful lot, is they get a lot of negativity through things like climate change, and then the world is a bit more precarious. You know, they can't afford a house, all this kind of stuff. Yeah. They're the first generation to be poorer than their parents, all this narrative. Whereas when I was young, as poor as little money as there was floating around in Ireland, I never felt poor of heart, because I always felt that space, maybe it was a more innocent time, I associated space exploration with this more positive, you know, outcome for humanity. And, you know, I worry a little bit that it's now China versus America, it's private sector versus the public sector.
Yeah, well, I think politics should be kept out of the skies, but I mean, that's never going to work, you know?
No, I think, you know, we're a bit tougher of a society these days, aren't we? Like, you know, there's less, even as they used to say, there used to be rules of engagement in war that are gone now, you know.
Yeah.
And the same, I think you're right with space. Even during the Cold War, America and Russia seemed to work quite well together. And you know, it's funny actually. There's an Irish author called Brian Harvey, and actually for Astronomy Ireland magazine, I had to review a book he wrote on the space, Russia and space. And I was staggered at how much cooperation there was over the decades between Europe and Russia, even during the Cold War. Actually, very much spurred on by President de Gaulle, Charles de Gaulle. He flew to Russia in the 60s, and basically kind of said to them, no matter what our political differences, let's try and work together in space. And they did. And that's why most European astronauts to date have been trained by Roscosmos, not by NASA, you know?
Cosmos, yeah, exactly.
And yet here we are now with Russia invading the Cold War. And what happens? ExoMars as a program is shut down. And so, like, you know, the all the advances in recent years of the Soyuz mission rockets were basically being launched from French Guiana. That's all stopped, you know. So we are in more divisive times space-wise as well. And I'd love to see, you know, a couple of visionaries come along who would help us all to traverse those barriers and start working a bit more collaboratively together, you know.
I think we need is another Apollo Soyuz type mission. Yes. Admittedly, everybody did say that even given the tensions on Earth between the US and Russia recently, the cosmonauts and the astronauts worked together. They politics to one side. We can't afford to do this, guys. We're in a deadly environment where if we let our politics get in the way, it's going to kill us. So they work together. And I think, to be honest,
hard using your brain.
It's really a case of we are going to have to cooperate. Most countries now have a space program. We brought ours back. We gave up ours back with Black Knight.
Well, you're coming forward again now, you know.
Yeah, and it was ironically, Black Knight was called the lipstick rocket because of the big red nose cone on it. It put Prospero into orbit, and it showed that you don't have to be one of the biggest superpowers to do it. The Russians have sold the N1 engine to an American company. They're now building it. They're using it to launch satellites. So Russian technology is still being used today.
You're right.
That N1 was designed to take Russia to the moon.
Yeah.
And the other side is people don't realize during the Cold War, if America had faked the moon landings, Russia and China would have been screaming out the fact and showing it.
Yeah.
Because they know how to track space debris, space rockets. They also know how to figure out where a signal's coming from.
Yeah.
And their press would be all over the world pointing out, well, this communication happened here and it was delivered late. They never said that.
Nick, that's a brilliant point, by the way. That's not very often used in these arguments with conspiracy theorists. I love that point. That's brilliant. Yeah. Because you're right, they were arch enemies at the time. They would have called it out. Yeah. Well done. I love that point.
Never was. And it was the first thing the Chinese did congratulate the Americans. So did the Russians. All right, it ended the Russian lunar man program straight away because why now keep doing something that's been done?
Yeah.
We're moving into an area of robotics at the moment. Most countries have launched a lunar robot.
Yes.
Some countries have succeeded, some haven't. The UAE has gone to Mars. They've got their orbiter around Mars at the moment. It's looking for methane. So countries can take part. Everybody is coordinating their Mars missions.
Yes.
So that nobody interferes with anybody else.
You're right. Well, and in fact, further than that, actually through JPL, what's called the Mars Exploration Program, you sign up to this, and so the UEA, and then the next bit of planetary study that has to be done, you volunteer, your probe will do it. So we're not duplicating effort as well.
That's really good idea.
Yeah, so in terms of Mars robotic exploration, there's a wonderful international collaborative effort going on there, actually. So that's a fair point. Yeah.
So we're doing it, even though it doesn't appear to be. We are cooperating still. There are tensions, but behind the scenes,
I would really love to see America and China do something together. I really would. Like America is more embargoing China than the other way around. I think China would be up for. I mean, I'm suspicious of China these days, as we all are, because there doesn't seem to be a dialogue with them. You know, they seem to don't want to talk. But nevertheless, I still feel they're more up for doing something international space-wise than America are. So I'd love to see America lower its guard a little bit and suggest something to China and for them to do it together. You know, I think it would happen.
It will happen eventually. It needs give and take on both sides.
But there would have to be cooperation there on both sides. I think there's so much, past. And I don't know. It would be great to see, though.
The other big thing is, of course, there is an international standard for docking collars. Right. Chinese use the same docking collar. The Indian Space Agency uses the same docking collar that Europe and America use for the ISS. We're all using the same standard. So theoretically, if there was an accident on the Chinese space station, either India, ESA, or the Americans can assist. They can get people off and save lives. Brilliant. So again, it may not have been intentional, and it may be one of those grey areas where they stole it, the technology. Who cares?
I would say it's more they discussed it at a technical level and thought this is a smart way to go. You know,
there is still technical discussions going on with all the sides, no matter what, because that way, if everybody knows what everybody else is doing, A, you're not going to needlessly duplicate something.
Yes.
And B, again, with the docking collar as an example, you have a potential where one nation can come to the aid of another.
Yeah. You have a backup. There's a slight bit of a safety plan. Yeah.
Exactly. And we've got Dream Chaser. That could be turned into a manned vehicle very, very quickly. Yeah. Sierra Research have everything set up for it to be manned.
Incredible.
But it's going to be it's going to be used primarily as cargo at the moment. But it has the possibility. They know what they need to do to turn it into a man-rated vehicle. Yeah. ESA eventually will, no doubt, man-rate the next Ariane version. 6 potentially could carry a manned capsule. Ariane 7 or 8 definitely could, because every new version of Ariane has more power, and it is more capable of heavier and heavier lifting. For sure. Which is why the James Webb Space Telescope was launched at Kourou, because Ariane had the rocket that could do it. It was too heavy for anything that the Americans have. The Delta Launch Alliance could not do it, but Ariane 6 was able to carry it. They built the fairings for it. They tested everything up on the ground, tested it all out. It worked. They went ahead, and we're now getting the science James Webb.
Yeah, the launch of Webb by Europe was, I think, really important because, our Mars, lander track record is not good, but in the few times we attempted it, but I think it's given great confidence to the Americans that we can actually do deep space well. I mean, it was, as you know, a very efficient launch, so it's given Webb even more years than they originally had hoped in terms of its thrust or fuel, possibly up to 20 years usage now, where they were projecting 5 to 10 years originally, and now we've just seen JUICE being launched as well by Ariane 5, so that's amazing. Well, so it's good. The only thing I'll say about Europe is, and I even do leave messages on the European Space Agency Facebook page, and this is that we don't spend enough on space, because we're as big an economic zone as the US, and we spend what if you look at, say, the US military and civilian spend, it's probably about 50 billion dollars in total, whereas Europe spends about 7 billion in total. So it's what's that, a seventh, and maybe about a quarter of their civilian spend. I mean, it's not enough. And the reason why I say it's not enough is China are now stepping up to the plate. China have been historically about the same amount to spend as Europe, but they're increasing theirs hugely. Yeah. And they've even arguably been more effective. Even though our Ariane 5 and 6 are great, I still think Europe could be more ambitious. And I think the country, and again, for anybody listening in on this, like the UK may not be in the EU, but ESA isn't an EU body, it's a European body. Right. UK is one of the most important members of ESA. But I think, and it's funny, just to get back to the UK, it is a great pity the UK stepped away from your space program decades ago, because you did have the economy to drive it. And I think, you are getting back there. Okay, you've had a setback now with Virgin Orbit, but by the same token, Cornwall will be a place, Scotland will be a place. I believe some sort of Virgin Orbit will return. You'll have Polar Orbit launching from Scotland, but we can scream our heads off about Boris Johnson all we like, but the one thing he was ambitious for space, and he put you back in the direction. You've got you've got a National Space Centre, I genuinely believe that a decade or two from now, the UK will be a very important space player on your own. You have the budget for it. I think there's a job for you done to convince the public of it, but I think you should be, because you're still the fifth biggest economy in the world. And I suppose what I'm trying to say is that it made no sense to step away from it in the past. I don't want to be too Irish about this, because we don't even have a space policy. All I'm saying is that the UK is a big country still. I know people kind of say it's not the country it used to be, but you're still a big, and France and Germany, I think, need to step up to the plate as well. Mm-hmm. I think France do. I think France's ambitions in space may be bigger than their budget, but Germany, I think, they just don't do enough. So I think even in terms of ESA budget, France puts in over $1 billion a year. I think Germany puts in about 800 million a year. So, and look, when you look at the size of the German economy, so, in terms of who's sitting at the table, slicing up how space is to be used in the next 20, 30 years, Europe isn't really at that table. You've got China, you've got America, and now you've got the private sector, you've got India. Okay, they're not there yet, but they've got huge ambitions. And where's Europe in this? So, I mean, the question is that do we want dark skies free of tens of thousands of satellites? And if we do over Europe, who's going to be at the table? And I think the UK, France, and Germany in particular, Italy as well, need to maybe be a bit more ambitious into the future. And part of that would be through a human space program. I think we haven't been ambitious at all enough in that regard, however costly it is, So I'm happy. The current president of the European Space Agency, I can't remember his name at the moment, has actually kind of stated what we're saying here is that Europe needs to be more ambitious and is looking for a greater partnership with America in particular. And that's why the launch of James Webb is important, why JUICE is important, and Airbus's involvement in Mars sample return in terms of the International Gateway, which buys us actually a few human seats out to the International Gateway. But I still think after all of that, sorry, I'm rabbiting on it here a bit, Europe is probably not ambitious enough space-wise to the tune of 2 or 3-fold. I mean, so imagine asking European governments to double their contribution to space. They're not going to do it. But I think they have to. I really think it's that serious, So we can talk about the returns from space, but the other side of it is, space is $450 billion a year is spent on space globally. Think about that. $500 billion. And we're not really a big player in that.
No, just a drop in the bucket.
Are we going to be left behind? So there's a lot of kind of high stakes involved in this as well, apart from the the philanthropic and the human societal dimension of it is very geopolitical aspect of this that I think Europe has to step up and play, driven by the UK, France, Germany, and Italy, maybe,
Well, the interesting thing is, Doina, who is part of the German military industrial machine, they are the prime contractors for the service module on Orion.
Who are, sorry?
The German aircraft manufacturer, Doina.
Okay, right.
They actually build the service module part of Orion.
Right.
They ship to the States.
Sure.
They mate it with the actual capsule, with the Orion capsule.
Yeah.
and onto the rocket. So Europe is actually involved in Orion SLS already.
Absolutely. And the logo is, ESA logo is there. No, you're absolutely right. And they are stepping up to the plate. And then again, Airbus involved with IHAB for the Lunar Gateway and so forth. So we are doing it. But nevertheless, if you look at the total spend, it's less than a quarter of what the US is putting into space. But we're actually a bigger economic zone, you know? And I think that just says something about our ambitions for space and how we're thinking about it, you know?
Well, and of course, the other thing is we have the military, industrial military complex in Europe. We have some very, very good companies who know how to build stuff and build it properly. We know how to test it, and we know how to deliver it. So we have the industries already in existence in the countries to do this. The other side of the coin is, if we wanted another equatorial launch place, we can go to Australia. That's where the British space program was launched from originally. It was Australia. It was Woomera in Australia. So there are lots of possibilities. And again, it brings in other countries into the mix, so they can put into the budget. Everybody puts into the budget. And of course, with ESA, the way it works is the number of people from your country working on the project is equivalent to how much you're paying in. So if Britain puts in, let's pluck a figure, 10 billion pounds into the budget, we get to put a large chunk of the staff in. So each country decides how much it's going to spend, and that allows them to put X number of people onto the project, which is in some respects is a great way, because that way it spreads the comeback from what the project does. So that expertise then gets passed on. So you've got people from Imperial College London, Queen's College in Belfast, they've got people from Dublin, all working on the same project. They're all talking to each other, and when they go back into the classroom environments, they are able to pass on. This is how you do a large multinational space mission.
You make a great point, Nick. Funny, for my own PhD, I had to write software for the Integral Space Probe, one of 4 instruments on it, and I became a European through it because I was working with people from Geneva, France, Spain, and it is amazing. For any young person, again, listen to this, what Nick's saying here is really important. First of all, Airbus, by the way, is bigger than Boeing. They're the biggest aerospace industry company in the world. And secondly, the UK is really a forerunner in this. And like the ExoMars rover was largely built in the UK. You've got great expertise here for satellite building already. And the thing is that, as you say, is what's wonderful about ESA, which again transcends the EU, because we're all part of Europe, is that, as you say, all projects are defined internationally. And what's amazing about the European Space Agency model, now it's probably similar in a way to NASA, but is say if you want to build Integral, which is an astronomical observatory, gamma ray, X-ray, and optical, then it's, as you said there, universities around Europe get together and propose the mission. They'll have to pull in some funding themselves, and they get some funding from ESA. ESA will launch it. They'll provide expertise. They'll provide, the infrastructure to build it. But very often, for example, individual universities will build individual instruments for the probe. And so if you're young, again, listen to this podcast, you want to get involved in space in Europe, actually, while I was being a little bit negative there, saying we're not as ambitious as we should be, actually there's great opportunity, because probably every major, certainly the big 7 universities in Ireland, all have astronomy and space programs in terms of not only undergraduate but postgraduate linked into ESA. And you can be absolutely confident every university that's worth its salt in the UK is equally linked in. So there's great opportunities. And again, just to hug the conversation here, but the last point to link into what you just said there is, when you join one of these missions, you suddenly realize, like I did, even coming to the table late in this, is that you're actually part of a wonderful European collaboration involving hundreds of other people. It's a great way, it's a great industry to be involved in. It really is.
Well, going back in history to 1986, it was the last apparition of Halley's Comet.
Oh, yeah.
And we all launched space probes. The Russians sent theirs, we sent ours. Yeah. And I actually worked on one of the instruments that went on board the European effort. Well, I actually had on my toolbox, which is currently in the States, I have the mission patch to Halley's Comet, and then onto Greg Sculler up. Now, I remember being allowed to use the boardroom facilities because we had video and stuff. I was watching literally live when the probe encountered Halley's Comet.
Wow.
And it was the most thrilling thing you can actually do, is to sit in a room on your own and you're watching the actual encounter, and then the particle. And
you were involved in it. You were involved in making that happen.
Yeah. I could say I actually did something on that. I was quality control, quality assurance. I had my hands on it. I made sure it met all the specs. I made sure that the clean room was operating correctly. That's all part of the mission.
Yeah.
And of course, we had Patrick, who was probably one of they were all looking to him for answers. So I haven't got any answers yet. We're waiting for the answers to come through, and until they come through and the mission scientists have looked at what's come through, then I'll tell you. But it really, really showed you what can be done. It was a European mission, and we all pulled together and we got it done.
Amazing.
It's just things. It just shows you what can be done.
Well, I'll tell you this quick anecdote. When I was leaving industry to go back to teach in Institute of Technology here, I was leaving a company called Sun Microsystems, and I was a Unix expert, but I wasn't a programmer. But UCD, an expert in UCD called Lorraine Hanlon, said to me, Kevin, you're going back to industry. Would you like to write some software for a space probe? I was thinking, well, I've got to do a PhD anyway. Okay. So we went to Geneva, right? Lorraine and I, into a little town outside Geneva called Versoix, and into this big boardroom where there's about 30 ESA scientists all sitting around chatting for about an hour. And then after about an hour, they all looked towards Lorraine and said, well, can you do it? And I was kind of thinking, oh my God, this meeting's for me, you know? So Lorraine looked at me, and I'd never written a line of C in my life. And she says, how does it sound? Like, I just said, yes. I went back to my hotel room and panicked. I rang my real supervisor, Nolan Smith, down in Cork IT, and said, what am I going to do? And the reason why I'm telling you this story is that then I went home to Ireland, and I said to my college, I want to teach C. So I learned C to teach it, to learn how to write it for the space probe. So the message I'm trying to put here is that you don't have to have prior expertise to get involved in this.
Yeah.
You can learn on the job. And even if you
learn on the job,
you know, and it was a wonderful learning experience. And eventually, when I told the people in my technical supervisor in ESA was a German man called Peter Kratschmar, a wonderful man. And when I told him around March late that year, a few months later, you know, Peter, you know, I don't know C yet. So now we 2 years to get this software written. They were completely fine with it, and then gave me the time to read the specs, learn the language, and then get in and get coding then. So the great thing about these sorts of programs is that everybody is kind of new to it. It's never been done before. And, you know, even the expertise you might have to learn, like I did, you'll learn on the job itself. So don't feel you got to be some kind of guru genius. You know what I mean? Very often I think young people thinking they might get involved in sciences or space science think I better be a mathematical genius to be able to do it. No, we're looking for people who are enthusiastic, imaginative, creative, you know, curious about the universe. And if you've got those characteristics, then, and you've got, you know, your wherewithal to work hard, then you'll do it on the job, you know. And that was my experience anyway.
Well, as I say, one of the great things is, I don't know how many people have paid attention to the Artemis 2 announcements. 3 of the 5 crew members are all radio amateurs. Wow. Which is telling me that potentially there will be a facility in the capsule for amateur radio enthusiasts.
Oh, brilliant. So
you can buy a general coverage receiver or a VHF receiver. You may actually get to listen in, like you can today, to the ARISS transmissions, where the astronauts speak to the schools and take questions live from school kids. And so another way, if you want to join in now, is get your basic amateur radio license. Then you will have the opportunity, quite likely, to talk to astronauts on a regular basis
as they travel around the moon. My God.
As they go around the moon, as they go around the Earth. It's one of those really weird things. They have already put up a 4G cell tower for the moon. That's already in the pipeline.
Yeah.
Because that way, if you go on the far side of the moon, you put the 4G cell tower on the terminator or on the line where you can see both sides, then you've got communications, or you use satellites. And again, if you've got radio equipment and aerials, you can track those satellites, you can listen into them. All space communications are done in Claire. They are not scrambled or encrypted. It is, anybody can listen to it without any problems. You need to learn a little bit about aerials, you need to learn a little bit about radios. And you have an opportunity, I think even more so, because the European astronauts, when they go to the ISS, they get issued amateur radio call signs by their own countries. Tim Peake had an amateur radio call sign. I believe his license is still active, but it's just one of those things. It's seen as a way to express what is going on during the mission to anybody in the street. So if you've got a license, or you have a buddy who's got a license, he may be able to call up the astronauts and speak to them and relay your questions. You have to be licensed to go on the air through amateur radio. However, I can tell you, if you've got a full license, you may allow somebody to say hello who's not licensed. They still have to sign into it. It can be done. Brilliant. So, and Southern Ireland has a great amateur radio community.
Yeah, I know several schools who have connected with ISS already, and in fact, we invited one to talk in our college. I'll tell you, you're touching on something amazing, citizen science. I mean, basically, a colleague of mine in college suggested that we run an evening whereby we don't do space talks ourselves. We try and find out what is the community doing in space. And one of the schools had talked to the ISS. They did it off their own energy. And then another school was also involved with ISS through what was called Astro Pi. Have you heard of this? Where basically kids program a Raspberry Pi that's sitting on the International Space Station that is connected to a thermal camera, an infrared camera that looks at the Earth, and then they can actually program it to survey certain areas. And one teacher here in Ireland was a biology teacher, and he had no programming skills, and he had 20 of his own first-year students, 12-year-old secondary school students get involved in this. And again, to your point, Nick, once they kind of expressed an interest and applied for it, then the European Space Agency gave them great support, as did NASA, to be able to fulfill it, even including teach them how to program and how to program Raspberry Pis. And it's amazing what you discover is being done or is being pursued by people in relation to space. That wasn't possible in our day when we were young. You know, if astronomy when we were young was get a telescope, join the BAA, whatever it might be. You know, these days it's get involved, as you say.
And getting the kids involved at 12, 13, especially talking to the ISS and actually, having some control themselves. That is just going to open up all of their minds. It's going to open up their worlds, and you will see huge amount more of those kids caring about what happens in the future and what happens in space and having an interest. Absolutely. So simple.
And it's incredibly empowering, and it would be likely that all of those children who would do that would be affected by it going forward. They think about this and think about their world, so it's great.
As I say, astronomy is a great tool to not only just educate, but to bring people together. There's a group called Astronomers Without Borders. They allow amateur astronomers throughout the world to talk to each other and share ideas, which is great, because they also share the culture as well. So you might have amateur astronomers in Iran, you may have them in China, anywhere. Most countries have a chapter like they do for the Planetary Society or the AWB. And it's
it's funny you say that, and they often say music is the international language. So is astronomy, because we all share the same stuff. And it's funny, it mentioned the Planetary Society, which I volunteer for, and this is not a hard sell, but they changed the way we do outreach about 3 years ago. I used to be called a coordinator to Ireland for the Planetary Society. That's gone. I'm just a member now, and I'm okay with that because times have changed. And now anybody who wants to, you don't even have to join the Planetary Society. You can become a volunteer. But one of the last meetings we had online as outreach coordinators was the outreach coordinator from Planetary Society from Venezuela, and he was communicating with us by phone. It was a kind of a phone conference thing during the revolution in Venezuela there about 5 years ago. And shocking, he was literally living down the road from where there were riots and where there was mass marches and even violence. and yet, you know, he felt compelled to connect to the Planetary Society, and we had Planetary Society members on that meeting from Pakistan, Australia, Venezuela, Canada, Ireland, France, all over Europe. It was an amazing idea. I'm sorry, actually, the Planetary Society don't quite do it now, although they do have a more broader volunteer system now. Anybody can just go online and connect to it, and then they'll offer you some help to try if you want to give talks and stuff. But nevertheless, to come back to your point, it was amazing to me to be connected with people in different, you know, very tough political jurisdictions, but we all shared the same thing in terms of a passion for space and astronomy. It's a powerful
universal language.
Yeah, it really is.
Well, you know what, Kevin, we've actually been on, we started at 1:30. It's 10 minutes to 3.
My God. Yeah.
So this is the fun thing about astronomy. We can
stay here all day.
And we go everywhere we need to for the show. You know, we're gonna have to have you back again.
I'd love it. You know what I'll tell you? I'd love to talk about Webb. Let's do it again in a number of months, and let's talk about Webb, actually, James Webb.
Yeah.
Going on there, and I think we'd love to share our thoughts on that. But
one thing I will say very briefly, on the last Sky at Night, George, Darren, she was showing us how they're building the instruments to see what may exist in the atmosphere of exoplanets. The scientists were actually using leaves and stuff so that they could analyze them, look at the light, the spectra through the leaf,
right?
So that they can now build the next generation of telescopes that will actually try to look at the atmospheres of exoplanets. That's how far we're getting already. And that one of the Wright brothers was still alive when Apollo 11 landed on the moon.
My God.
Yeah, it was actually on Patrick Moore had one of them, the surviving brother, on his show to talk about it, how quickly from first flight to first moon landing it's been.
Yeah. Well, do you know what? And I'll finish on this point. I mean, I'm 57, but I've already feel I've outlived all my dreams as a kid in astronomy. Like, discover planets around other stars, the Hubble Space Telescope, artificially intelligent rovers on Mars, the voyagers beyond the solar system. I couldn't have imagined that even in the 80s, just 40 years ago. And this is extraordinary, isn't it, that we can achieve these things, and it's only going to get better into the future. So again, I'll just finish by saying any young person involved, wanting to get involved in this, you're getting involved in a very exciting topic for the future.
We've also discovered active volcanoes in other places in the solar system. That again, Voyager showed us them when it was transiting one of the Jovian satellites. The sun was behind the moon, and we saw active plumes, geysers coming off the surface of the moon. We found water. We found sulfur volcanoes. We've even found potentially water on Pluto. And when you think how far away Pluto is, it has water.
Incredible.
How many people would have thought we'd have discovered that by now? And we've done it. We have actually seen the surface of Pluto.
Even to have seen Pluto, it was just this remote speck.
Yes.
Seeing it up close, it's wonderful, isn't it? You know.
What can happen next? We don't know. What will we find? Will we find life on Europa? Will we find life on Enceladus? The potential is there. Maybe even Titan may have a form of. Who knows?
None of these things are beyond possibility at all anymore.
And again,
the realm of reality.
Yeah, and sorry if I'm sounding like too much messaging towards young people, but you know, it's going to be the next generation who figure out how to find out these answers. You know, we don't know yet, because the people they're in school right now and they don't realize building these space probes within 10 and 12 years. You know,
JUICE, the stated mission of JUICE is to map the Jovian satellites in greater detail. It will also lay the foundations for a landing on Europa. And
also, it's just deciding if it's planetary or if it's habitable. I mean, the fact that we're even looking into moons being habitable close to us, and we're going to have them as like put that way, and not just dead worlds, you know.
And the way it's going to traverse around the Jovian system, it's going to go from moon to moon is a whole different way of the exploration in itself, you know. Very exciting.
Previously, all we could best do is to do a flyby going somewhere else. Now we have tailored missions. Europa Express should land on Europa. Hopefully it will be able to drill through the ice. Hopefully it will be able to sample the European Ocean. And we don't know what, we may even find very primitive life in the side oceans there. Again, all science fiction until now. It's becoming... Anyway, I know that you've got a busy day, Kevin.
Pleasure. Thanks for having me, Nick. I really enjoyed it, and let's do it again. But it's a deep pleasure and honor to be invited on. So thank you so much for that. Well, so thank you for coming on through a second visit. We know you're going to have a third visit, probably a fourth and fifth. Time just flies. Looking forward to it. So great.
Thanks very much, Kevin.
Cheers, Ron.
So goodbye from me.
Goodbye from me.
Thank you. And goodbye from me. Bye-bye.
Bye, Kevin. Thank you.
Cheers, guys.